Welcome back to Mr. Hassan's Maths channel. I'm now answering question number 5 from the June 2023 Pure Mathematics P2 paper. And this question is all about logarithms. And this is a topic where some students, they start doing some really weird things. Okay, like their normal kind of maths logic kind of goes out the window. And that's mainly because this is something they never encountered before in their earlier maths life, this new log function. And maybe when they're taught about it, they're not really taught about it in a way that relates to what they know from before. It's just like something totally new now. This is a log function and these are the rules or logarithms. And they don't really have any idea what they're related to or where they come from or what even the log function actually means. So it's like an alien kind of concept to them. And then the laws of logarithms, they don't really appreciate them, and they start doing all sorts of weird things which go completely against any type of mathematics logic in trying to solve such a question. All right, so I'm going to just briefly go through some of the laws of logarithms and explain where they come from a little bit, such so that you have some kind of make it a bit familiar for you. So the first thing is, what is a logarithm? Right? What is a logarithm? Well, just like for example, if I take something like x and I add 3 to it, okay, let me just say I take 2 and I add 3 to it. I know it's going to give me 5. How am I going to get 5 to become 2 again? Well, I can just take away the 3. It's going to give me 2. So like the opposite or inverse operation of adding is subtracting. So if I add something to a number, right, to get that number going back to what it was in the first place, I do the opposite, which is subtracting that same number that I added. Okay, same with subtraction, same with multiplication. For example, if I take 7, or let me take for example 8, and I divide it by 2, it's going to give me 4. How am I going to make 4 become 8 again? Well, I have to do the inverse of division, which is multiplication, and that's going to give me back to where I started, 8. Right, it's undone that function. It's the inverse. Okay, the inverse undoes something, right? So for example, if I so now let's go straight into this. So the log function exists to be the inverse of the exponential function. So for example, if I take the number 2 and I raise it to the power of 3, that's going to give me 8. Now, how am I going to get 8 to become 2 again in this similar kind of way? Well, what I can do is I can take 8 and I can put it inside the log to the base 2 function. And that's what's going to give me 3. That's what this function is there for. It's to undo the exponential function. So if I raise something with a base of 2 to 3, gives me 8. How do I get the 8 to become 3 again? I put it inside the log to the base 2 function. And that will take me back to 3 again. So that's what the log function is based on. It's based on being the inverse of the exponential function. It undoes it, right? So therefore, what we can understand from that is that the laws of logarithms are basically based upon the laws of indices, right? So before we go into that in more detail, the first thing we need to know is log to the base a of b equals c. Can be rewritten in the index form. A is the base, okay? That's the base. The c is the power, and the b is the result. That's the same thing in index form. If you raise this number, if you raise 2 to the power of 3, you get 8. A to the power of c equals b. So you can rewrite something in log form in index form, and you can rewrite something in index form in log form using this idea. Okay, so that's the first thing. Okay, secondly, what we know, there are certain laws of logarithms. The first law of logarithms is basically based upon the law that we know from indices, that when you have two numbers in index form with the same base, raised to a certain power, okay, multiplied, so you have two numbers to the same base multiplied together, all right, you can add their powers and write them to that same base. So it's like you can write them as one term, but we add the powers. But the bases must be the same. The bases must be all the same, otherwise it doesn't work. So from this law is derived the law of addition for logarithms. So if I have two numbers to the same base, okay, added together, then I can rewrite this. What am I doing? To the same base. I can write this as log to the base a of m plus log to the base a of n equals log to the same base a of m times n. So I can write that to the same base, log to the same base of the product of those two. So that's the first law of logarithms, because they call it the addition law sometimes. All right. So, but they have to be the same base. Just like when you multiply two numbers in index form, you can combine the powers by adding. If the bases are the same only, the same thing here. If the logs are up to the same base, and you have log to the base of something plus log to the same base of something, you can add those two together and combine it into one logarithm. So it's kind of like, a similar law to this. Okay, it's based upon this law. That's the first law of logarithms. Now, the second law of logarithms is based upon the other very famous, index law, that when you divide two numbers with the same base in index form, you subtract the powers. Okay, which leads us to log to the base a of m, okay, minus log to the base a of n is equal to log to the base a of, and we can divide those, m over n. Okay, so that's sometimes called the subtraction law. So that's the second law of logarithms. Okay, when you have two numbers or two numbers inside the log to the same base, okay, and they're subtracted from each other. Okay, so you have log to the base a of m minus log to the same base a of n. You can combine them together as one log term, log to the base a of m over n. Okay, that's the second law of logarithms. And the third law of logarithms is basically kind of something where, like, supposing I have log to the base a of b plus log to the base a of b plus again log to the base a of b. And I can continue if I want to. Now, I can rewrite this in two ways. I can say here we have three lots of the same thing. That would be 3 times log to the base a of b. That's one way I can write that. I can also write it, and I can combine these into one logarithm using this first law here, right? So I can say this is log to the same base of, and I can multiply the b by the b by the b. So it doesn't matter, like if, for example, if I had if there were 4 of them added together, that would be a 4 here, and that would be b times b times b, b times b, which gives me, in the end, log to the base a. In this case, it will be b cubed. But if there were 4 of them, it would be log to the base a, b to the power 4. If there was 5, this would be a 5 here, and that would be a 5 there. If there was 10, there would be a 10 here, and there would be 10 there, right? Because you would add 10 of them together, and you would multiply 10 of them together. All right, so now that means these two must be the same. That means log to the base a of b cubed must be exactly the same as 3 log to the base a of b. Okay, so that leads us to our next law of logarithms, which is log to the base a of m to the power of n is equal to n times log to the base a of m. Okay, it's called the power law. Okay, so this is the third law of logarithms that we need to know. Okay, so these 3 laws, along with this fact here, okay, are really important for us to know. I've just highlighted them. I'll kind of keep this separate and keep it there so that you can see. I won't erase it. Okay, so we've got these laws of logarithms, which will help us to understand how to answer any question on logarithms if we just apply these laws. Okay, so can't see if that's very straight. Is it straight? That's better. Okay. So those laws of logarithms are going to help us a lot in answering such questions as these. Okay. Okay. All right. So that's something important for us to know how to deal with. All right. So those 3 laws of logarithms. So sorry if you already understand this really well, but I know that there are a lot of students who struggle with the topic of logarithms because simply it's alien. So either you skipped what my explanation and you came straight to the answer, or maybe you learned something. Maybe you knew what to do, but you didn't understand why we do what we do. Hopefully you would have benefited from some of this explanation that took place before. Now we're going to actually answer this question. And hopefully now, those of you who didn't understand logarithms before will appreciate what I'm going to do now. Now, I'm going to first look at some of the big mistakes people make. One of the biggest mistakes people make is they think that because the laws of logarithms are alien to them, they think they can do something. Okay, all right, we can just just get rid of the logs. Just write it as 16x plus x plus 1 equals 3 plus x plus 6 or something like that. Just get rid of the logarithms. Okay. Or some of them say, okay, what we can do here is some of them will say this. Okay, let's write this as log to the base 2 of 16x plus log to the base 2 of x plus 1 equals, and they'll say this is like 3 times log to the base 2 of 2, okay, equals log to the base 2, plus log to the base 2 of x plus 6, because we know log to the base of 2 of itself is going to be 1. Log to the base 2 of 2 is equal to 1. Why? Because 2 to the power of 1 equals 2. So some people will do that, and they'll say, okay, now we can just get rid of the logs. So say, let's get rid of the logs. Or they'll say, first, let's use the power law, make this 2 cubed. That's going to be 8. Okay, so say, let's get rid of the logs. 16x plus x plus 1 equals 8 plus x plus 6. And that's completely wrong. You can't do that. You can only, you can't just get rid of the logs like that. You could, if there was one log term on this side and one log term on that side, and they were to the same base, then you can equate what's inside those logarithms. So that's something you cannot do in logarithms. You can't just do that. You have to write them as one log term first. So in either case, we have to combine these together, these log terms together. We must combine them together. So what I'm going to show you here is now how to do that. So what I'm going to do first, I'm going to take the left side and I'm going to rewrite it as log to the base 2 of, now we have this law to apply. You have log to the base 2 of something plus log to the same base 2 of something else. We can write those two things inside one log function, but as a product of those two things. Okay, and here we have 3 plus log to the base 2 of x plus 6. Now there's different ways people will continue from here, okay, but personally the way I like to do it is bring all the log terms to one side and leave the constant terms on the other side. So now what I'll do is I will subtract log to the base 2 of x plus 6 from both sides, and I have log to the base 2 of x plus 6 equals 3, and then I will combine these two together using the subtraction law here, right? So I have log to the base 2 of something minus log to the base 2 of something. I can use the division law. I can say log to the base 2 of the quotient of those two things, 16x times x plus 1 over x plus 6 equals 3. All right, so now once I've got to that stage, I can apply this understanding that I can rewrite this now in index form. It's in log form. I can change it to index form, and I know that a is the base, so I'll have 2 as my base, and c is my power, so 2 to the power of 3, and what's inside the log function is the result of this, so that's going to be equal 16x times x plus 1 over x plus 6. Okay, so if I try to start simplifying this will be 8, multiply both sides by x plus 6 to get rid of the fraction, equals 16x times x plus 1. Now I can divide both sides by 8. That's going to be 2, so I have x plus 6 equals 2x times x plus 1. And now if I expand this, I get 2x squared plus 2x. And then I can see I've got a quadratic equation to solve. So I have 2x squared. I have 2x minus x, which is plus x. Take away 6, minus 6. So I have to solve the equation 2x squared plus x minus 6 equals 0. Now to solve this equation, we have to show that we factorize. You can't just use your calculator function, otherwise you will lose marks. You can't just put the a as b, a as 2, b as 1, and c as negative 6 in your calculator using the equation function. If you just wrote x equals and x equals as your answers, you will definitely lose some marks. So you have to show that you factorize. So if you can factorize this by guess and check and just thinking, that's fine. I mean, you can, it's not too difficult to do that. You can say, that must be 2x and that must be x. Sure. One of them has to be positive, one has to be negative, and you have to end up with a minus 6. So you're gonna think of like 5 and 1, or you can think of like 3 and 2. It seems like to me it's going to be 3 and 2. I think the 3 has to be here and the 2 has to be there. That's going to give you 4x, and that's going to give you 3x. So it must be plus 4x and minus 3x. So you see this will give us an answer. 2x squared plus 4x minus 3x and minus 6. So it's not too difficult to do this by guess and checking, but some questions it's a bit more difficult because you have more combinations. So you can guess and check, but you have to show that you have factorized. You can't just say x equals and x equals. That's something that's important. You will lose marks for. I mean, in general, this is how I would solve it. I would solve it by splitting the middle term. I have my own little way of splitting the middle term by using this kind of grid. That's how I like to do it. It's the same basic concept. But basically, I put the first, it's 2x squared here, by the way. I put the first term there as 2x squared, and this has negative 6. So the x squared term here and the term here, I don't know if I wrote the x squared there, maybe I didn't, but it should be x squared, of course, there, as is written there. So 2x squared and negative 6. So I know that these two numbers in these two parts of the grid must give me a product of negative 12x squared, right? And I also know that these two numbers in this part of the grid, when I add them up, I get this middle term, which is going to be plus x. So the sum of those two has to be plus x. So we can think of these two numbers as 4 and negative 3. So I can write 4x here and negative 3x here. Those will multiply to give me the same as these two, 12x squared, negative 12x squared. And when I add them, I'm going to get plus 1x. Okay, so that's exactly what I need here. So now I can take this row here and factorize it and write the common factor out here. The highest common factor of this is 2 and x. And once I've done that, then the rest is really simple. I can just say, okay, this box here, its area is 2x squared. So 2x times x must have given us 2x squared. And this box here, its area is 4x. 2x times 2 gave us 4x. And this box here, its area is negative 3x. X times negative 3 gives us negative 3x. So we end up with 2x minus 3 and x plus 2 as our factors. So now I know that either 2x minus 3 equals 0 or x plus 2 equals 0. So x equals 3 over 2 or x equals negative 2. So those are our two solutions. Now, a lot of students will stop there and they will give these answers as their solutions and they will lose some marks. Because with logarithms, we have to always check, do the answers that we get when we solve such a quadratic equation, do they cause any problem in the original function? So this was our original equation that we had. If I substitute these values of x into this, okay, a problem will be caused if any of the inputs of the log parts of them are negative, for even one of them, right? If one part of these log functions gives a negative input, has a negative input, then the output will be undefined. The log function does not have any negative input, right? Just like if 2 to the power of x can never have any outputs that's negative, then the log function can have no input that's negative, because the log function is the inverse of the exponential function. So 2 to the power of x can never go below y equals 0. So the log to the base 2 of x, this graph would look like this, can never have any x value which is negative or even 0, right? So that will cause it to be undefined. So of course we can see if I put x equals 2 in negative 2 in here, I'm going to have a negative over here, a negative over here, right? So those two terms, they're going to give me something that's undefined. So if I put x equals negative 2, okay, you're going to have some undefined parts of this equation. So therefore, x cannot equal negative 2. So therefore, we can say x must only be 3 over 2. If I put 3 over 2 in here, that's going to be positive. That's going to be positive. That's going to be positive. That's no problem whatsoever. And we can even check our answer if you want. If we replace the x with 3 over 2, then this side should be the same as that side. You can even check it if you want to, right? But we must state the solution that we chose, and we must reject the solution, the other solution. We must show that we rejected it, right? So it's very important for you to do that, to show that you've chosen the correct solution, because this will give us log to the base, this will give us log to the base 2 of negative 32. Just that alone can't occur. You can't have a negative input, right? So because of that, even if it's one of them that becomes negative, the other is positive, you cannot accept that value. So x equals 3 over 2 is our final answer for this question. I know I took a long time in answering. It's a very quick question, really, actually, but I just wanted to kind of get rid of some of the misconceptions that people have in the logarithms topic and make it feel a bit more familiar for you. so you can understand where these laws come from. Sometimes if you understand where the laws come from, you appreciate them more, and you respect them more, and don't do like some weird things which don't make sense. Okay, so there's the answer. Other questions from this particular paper, you can find the video solutions in the playlist that will appear over here. The link over here will take you to the playlist involving logarithms in general from P2. You can subscribe to my channel by clicking on this link, and you can watch a video which will be linked over here, which tells you how to use my channel to find the things that you're looking for, whether it's A-level, Cambridge A-level, IGCSE, whatever you're looking for. Whatever material I have, I've given some ways you can find the index for those things to find things easy. So thank you very much for watching, and see you soon.